What is the sender doing while it's waiting for the ACKs for those 3 packets to come back? It's not doing anything. So if we really want what we call an ACK clocking behavior, where every time I get an ACK, I put a packet in, then I need my window size to be the round trip time, the delay going to the receiver and coming back times that bandwidth. Any questions on this? Is it clear? Yeah? Okay. So that's the window size. We're going to try and set the window size based on the round trip delay. So now let's talk about what we can do in terms of design options now that we have multiple or W packets in flight. So what we've been talking about so long, all this time, is what we call individual packet ACKs, which is when the receiver gets packet I, it sends back an ACK saying ACK I, meaning I received packet I. If you look at this in the context of a window, you'd realize this, we could be doing better. So here's an example where I sent 4 packets, all 4 of them made it, but ACK 2 was dropped. With the protocol we've been designing so far, what would the sender do? It would take a timeout on packet 2, because it never received the ACK, and it would resend it. But packet 2 was actually received at the receiver. And the receiver sent me 2 other ACKs, or a bunch of ACKs after that. Right? So this should tell you that you could put something into the ACKs that would allow the sender to kind of tolerate the loss of an ACK, to figure out that packet 2 had reached even later. Thoughts? What would you do? You get to redesign ACKs now. A new type of ACK. Yep. I'm going to take that and flip it around. You're getting there. What you could do is something we call full information ACK, which is when I send an ACK, I tell the sender all the packets I have received so far. Because why should I only tell you about one packet? I can tell you about all the packets I've gotten so far. Right? So the way this would work is you would give the highest cumulative ACK, which means that you've received all packets up to that sequence number, and then any additional packets that you received. So something like I got everything up to sequence number 12, and then I received packets 14 and 15. What would that look like here? So with cumulative ACKs, your ACKs would now look like what you have there on the right-hand side. Right? You'd be saying, I got everything up to 1, everything up to 2, everything up to 3, up to 4. So in this case, trivially, the minute the sender received the ACK for packet number 3 or the ACK for packet number 4, it also knows that you received 2, and so it doesn't have to retransmit 2. Clear? This was a pretty case. It doesn't always look this pretty. Let's say that in this case, you lost every other packet. So you lost packet 2, you lost packet 4. So what do your ACKs start to look like in this case? So when you got packet 1, you said, I got everything up to packet 1. But then the ACK when you got packet 3 says, I got everything up to 1, and I got 3. When you got packet 5, you say, I got everything up to 1, I got packet 3, and I got packet 5. Right? So you can see that the information you're starting to put into your ACK is not scaling so well. Right? It's starting to get kind of long. Is this making sense to everyone? Yeah. So we like full ACKs, full information ACKs, because they tell the sender exactly what's going on at the receiver. There's no guesswork. But the problem with them is they don't scale very well. There's too much information in there. In the worst case, you could have as many, the size of your full information ACK could be on the order of your window size, which can be tens of thousands of packets in practice. So that brings us to our last type of ACK, which is kind of trying to achieve a sweet spot between the first two. It's what we call cumulative ACKs, which is saying, I'm going to take the idea from full information ACKs of telling you what's the highest sequence number I've received, such that I got all packets before that sequence number. But it's going to drop that trailing edge of which other packets have you, out of order packets have you received. Okay, so it's just the highest sequence number for which all previous packets have been received. Any questions on what cumulative ACKs means? Okay. So let's see them in action. So in this, going back to that example here where ACK2 was lost. So in this case, the cumulative ACKs, interestingly, look exactly like the full information ACKs. And that's actually not surprising because we didn't lose any data packets. So the ACK is just telling me I got everything up to the packet number 2, up to 3, up to 4. And so in this case, cumulative ACKs behaves exactly the same as full information ACKs. The minute you get the ACK for packet 3, you know that it also received 2. The sender is not going to retransmit 2. In the case where I lost every other packet, like packet 2 and packet 4 in this case, this is where you start to see a difference between cumulative ACKs and full information ACKs. Right? Because in every case here, the receiver is just saying, I got all packets up to 1. Right? So cumulative ACKs, it scales better than full information ACKs, but it can be ambiguous about exactly what the destination received. We've lost some information there. And as you are going to see when we start designing TCP, TCP uses cumulative ACKs, and TCP tries to guess what the receiver has seen. And so things get a little tricky. There is one thing to note, though, that every time you get one of these ACKs, you are learning something about the receiver. You're learning that the receiver received some packet. You're just not learning exactly which one it received. Let me recap the ACK trade-offs, and then let's pause to see the question. So individual ACKs, this is when I get packet I say ACK I. It's very simple. It's very compact. The problem is if you lose an ACK, you will always have to retransmit that packet. You would always have to take a timeout and retransmit. And remember, we don't like timeouts. Okay. With full information ACK, suppose you have all the information you want. There's no ambiguity. You're completely resilient to ACK losses. The problem is it takes a lot of overhead in the ACK packet to actually enumerate all these packets. And so cumulative ACKs, they are compact. They are as compact as individual ACKs. They are more resilient to ACK loss. So as you saw when that ACK was being lost, cumulative ACKs recovered from it. But it is incomplete information on which data packets were actually received. You have a good indicator of how many packets were received, but not exactly which ones. Any questions on this? Let me pause here. Yep. Well, so for example, in the case where you had the ACK loss, right? If I had individual ACKs, I was retransmitting packet 2 here because I never received any information about packet 2. But here, when I get the cumulative ACK for packet 3, it's telling me I got everything up to packet 3. So the sender knows not to resend packet number 2. Right. So for the next case, you're right. It doesn't know. And this is going to come back to trouble us. But it does tell us something, which is the presence of an ACK tells me that a new packet was received. So I know how many packets were received. I don't know which ones. If you're feeling like, I don't like cumulative ACKs, I agree with you. But those are the trade-offs that come with it, yeah. Yeah, so I think the question is, why don't we do a better job of trying to scale full information ACKs and say that I'm going to give you full information on some piece of it? Is that yes, and so that is something, it's approaching something called selective acknowledgements that TCP uses. The reason we talk about cumulative ACKs is TCP uses cumulative ACKs because they were really concerned about keeping ACKs small. Over time, there's been this new extension, SAC, or selective acknowledgement, that we'll also cover. But yes, you're absolutely on the right track. I think the question's all, there's a spectrum between cumulative and full information, and it's an interesting design point. Yeah? Why wouldn't you send which ones you didn't? Well, you could. It's a reasonable design to consider. I would have to actually walk through the case, but here would be my intuition, would be when I tell you which packets I received, that's correct information. When I tell you which packets I didn't receive, it might just be delayed and coming in. So if I tell you I didn't receive 2 and then I receive 2 right after I send that, the sender is going to retransmit 2, if you believe the information. Any other questions on ACK types? Okay, so we use these ACK types. Some of them is, they're what is used in protocol. Some of them is also just to show you the design space. It's not the only kinds of ACKs you could come up with, for sure, but these are the ones we're running with and sort of analyzing. So with that, what do these ACK options mean for detecting loss, right? So far we've been saying that the way you detect loss is that you have a timer that expires. So if the packet times out, you assume it's lost and you resend. But now that we have all these ACKs coming in, as you've already started figuring out, you can actually look at the ACKs that you're receiving and use that to decide whether you think something is lost. Okay, so a reasonable rule is to say, I'm going to look when I receive k subsequent ACKs after the packet I was expecting. So I was expecting a particular packet ACK, and if I didn't get it, but I got k subsequent ACKs for other packets, then maybe I can decide that that packet is actually lost. Right? So as an example, let's say that only packet 5 was lost. So at the sender, I had sent a whole bunch of packets, and I've received ACKs up to 4, and I'm expecting 5. I'm expecting an ACK for 5. Right? And I haven't received an ACK for 5, but now I receive an ACK for 6. So when I receive the ACK for 6, you could think, well, okay, maybe there was a little bit of reordering, maybe the ACK for 5 was delayed, so I'm going to hold on. When you receive the ACK for 7, you feel like, okay, that makes 2 ACKs I got that were beyond what I expected. Maybe packet 5 or ACK 5 was really lost. And so you can go on that way, and you have some number of k, which is after you've gotten k subsequent ACKs, you decide, okay, the packet I was expecting is lost. I'm going to treat it as lost. Yeah? It depends which ACK mechanism we're using. So you're right, it'll be a little different depending on what type of ACK we're using. But I will receive an ACK for that packet. What I mean by that is that data packet 6 arrived. It caused the receiver to send me some ACK, and that I'm receiving an ACK corresponding to packet 6. It's not necessarily an ACK that's telling me this is packet 6 was received. And we're going to do that in just a second. Right? So exactly how this looks depends on the ACKs you're using. So let's actually walk through this. Right? So let's say we had individual ACKs, and only packet 5 was lost. If you look at the stream of acknowledgements that the sender is receiving now, right? This is individual ACKs. So I receive packet I send ACK I. You're going to see a stream of ACKs that look like this. As you can see, we never got an ACK for packet 5. So after we've said k subsequent ACKs, so in this case, let's say it's 3. So after I've gotten an acknowledgement for packet 6, 7, and 8, the sender is going to say, by this rule, it's going to say packet 5 is lost. Okay? So we're going to treat this as equivalent to a timeout. At this point, we've decided packet 5 is gone. Yeah? With full information, it's exactly the same story, except that it's even more explicit where the hole is, because the ACKs you're getting from the sender are going to tell you, I got up to 4 and then I got 6, and so on. And when you receive that you got up to 4 and 6, 7, 8, you can see that the receiver received 3 packets beyond 5. And so you can declare by this rule that packet 5 is lost. Yep. What about with cumulative ACKs? And this is where cumulative ACKs come back to bug us a bit. Right? So what your ACKs would look like in this case is when you had packet 6 arrive at the receiver, it sent back an ACK saying, I received all packets up to 4. Okay, so we call these duplicate ACKs because they're saying the same thing as when we received packet 4, when we got the first ACK for packet 4. Okay? And so the same rule in this case with cumulative ACKs says, after we get 3 duplicate ACKs, or dupacks is what we call them, then we say that packet 5 is lost. Yeah? As someone already pointed out, there's a hitch here with cumulative ACKs, right? I got 3 duplicate ACKs. It tells me that the receiver received 3 packets, but I don't know which packets these are. I don't know that it was 6, 7, and 8. It could have been 7, 8, and 9, for all I know. We don't know. We're going to have to deal with this.